cleanup of environmental hazards at the Department of Energy's Oak Ridge site is an issue that affects us all. DOE is working to address the issue, but it needs citizen input. One way you can help is to take part in the meetings of the Oak Ridge Site-Specific Advisory Board, a volunteer citizens panel. By attending meetings, you can learn about the cleanup program and voice your opinions. Join us in making our area an even better place to live. For more information, call toll-free or visit us online.
First of all, I'd like to start off by thanking everyone for attending our monthly board meeting. We'll go over a bit of board business to start with. We'd like to ask the guests to please sign in at the front, to wear your name tags, and to use a microphone to have questions or comments. Our next board meeting will be Wednesday, April 11th, and the presentation will focus on the U-233 project at ORNL. Later in the evening, we'll have a presentation on the status of the East Tennessee Technology Park cleanup, and that will be by Mr. Jim Kopodic. Afterwards, we'll have a period of time for questions and answers, and questions will be taken from the board members first and then the public. Would like to remind the board members to please use your name tags. Let's move on to the comments from the Deputy Designated Federal Officer, Sue Cange. Just in time.
Perfect timing. Good evening, everybody, and welcome to our new home site for the Site-Specific Advisory Board. I am very pleased to see how everything looks, and I hope that you all find this new facility to be to your liking as well. I had a couple of comments I wanted to share with everyone. First and foremost, for those of you that may not be aware, Mr. John Eschenberg has been asked and accepted a position with the National Nuclear Security Administration. Fortunately, he's going to remain here in Oak Ridge and will be the federal project director in charge for the uranium processing facility, which is the department's largest new construction that's going to be underway here in Oak Ridge. So we're very happy for John and for NNSA and for the UPF project as well. I think it's an excellent fit. So I just wanted to make sure that you all were aware of that. He will be transitioning over the next several weeks to that new position. Also, I wanted to talk for just a few moments about the fiscal year 2014 budget and the budget formulation process. We did have a public workshop 2 weeks ago to gather public input on that budget formulation process. We've gotten a couple of comments and also had some questions at the workshop. Basically, what we are doing in-house is working on developing a couple of different funding scenarios, a couple of different planning cases, and we will be sharing those cases with headquarters at the end of the month. We have, as a part of our formulation process, also had multiple communications with our regulators, both TDEC and EPA, to try to make sure that we're all on the same page with regard to what the priorities are and what they need to be, and also to identify what milestones we should put in place for those priorities. And so we've made excellent progress in that area. And I think that it's a good example of the three agencies collaborating and communicating. So I'm very, very pleased with the progress we've made there. The priorities, in terms of the near-term priorities, are consistent with what has been communicated to you all in the past. It's to complete the demolition of the K-25 project, and that's something that Jim Kopodic is going to talk about tonight. As well as to continue with the direct disposition activities for the uranium-233 project, to continue with our processing of transuranic waste, and to identify early actions and prepare for our longer-term actions to address mercury at the Y-12 site. So that's really where the focus currently is and where it will continue to be for the next couple of years. On the project side of the house, I wanted to just let you all know that the tank W1A project, also known as Core Hole 8 at the Oak Ridge National Lab, is near completion. Our contractor UCOR has removed the tank. It has been shipped off-site for disposal. They've completed excavating all of the contaminated soils, and the last remaining boxes are being shipped out. They have grouted the excavation area and will be finalizing their field activities and demobbing over the next several weeks. So we're very pleased with the completion of that important project. And that's it in terms of a summary of activities. Any questions?
Could you give a little more information on the grouting over the ground after removing the tank? Is it just filled with concrete, or is
It's actually a special type of grout. Cheryl, do you or anybody know? It's not just concrete, but do you have any information?
everything that's in there that leaked around the tank is still in there?
No, all the contaminated
taken
soils
out?
have been excavated,
So
boxed
the
up.
tank and some distance around it?
Yes, all, not just the tank, but all of the contaminated soils surrounding the tank have been removed and boxed up and are being shipped for disposal. Yes. Anything else?
Is it too early to make any judgments on the plume below the W1A tank area?
Well, we have a fair amount of information already about the groundwater plume that is in that vicinity, and in fact, we have an active treatment system that is currently withdrawing the water and treating it.
Is it starting to
Is it
show some
working?
results? Is it getting
working?
cleared up? That's the idea
Yeah.
behind it.
Yeah, it will over time, we certainly expect. It's too early now. I mean, basically, a lot of the contamination that's in the groundwater is from historic releases from at the site. It's down in the groundwater fairly deep down and welling up into a stream to the west. By removing the tank and the contaminated soils within a box area around it, we'll be cutting off that continued loading into the groundwater. We've got treatment systems that are actually going directly at the plume to control it and withdraw it some. Generally, groundwater quality improvements for a project like this are not measured in days or weeks, but really in quarters and years. So we'll be monitoring it as part of our environmental monitoring program in the next few years, and we expect to see improvement in the quality of water.
What about the pipes that fed the tank? How far did y'all go up and removing them in the trench?
We took out everything that was agreed to be taken out as part of the removal action document that we signed with the regulators. It's basically a box-shaped area, roughly the size of the interior of this. We did not pursue up the hill. I believe you're referring to some pipelines that come down from the 3019 facility, where we know we have additional contamination along specific spots on that pipeline, and most certainly beneath the 3019 facility. We did not have money to chase the pipeline up the hill. Candidly, even if we had, we would have had to have stopped this side of 3019, where there would have still been more contamination. So that cleanup job is ahead of us, along with a lot of other soil cleanup work at Ornell, and it was left in place. Sure.
Any more questions for Sue? If not, we'll move on to our DOE liaison, Dave Adler.
I just had one quick thing to share. At the executive committee, Steve asked a question about mercury contamination at Oak Ridge National Laboratories, as opposed to the mercury contamination that we talk about a lot at Y12. And he asked me to chase down some information on that and on beryllium. What I was able to find by talking to Jason Darby, who's our environmental monitoring guy, the processes used at Y12 for lithium isotope separation, a process referred to as the Colex process, was developed at Oak Ridge National Lab, just like the plutonium separation processes employed at Hanford and Savannah were developed at Oak Ridge National Lab. So there were some very small-scale experimental systems developed at Oak Ridge National Lab that involved the use of mercury, far, far, far smaller quantities than the millions and millions of pounds of mercury that were used at Y-12. During those early developmental activities, some mercury was spilled in the 4,000 area. The 4,000 area is basically what we think of as the modern laboratory, not the old central campus. And about 2007, we started noticing some problems with water quality in water that was upwelling into a sump in one of the basements of those buildings. So in 2009, we put in a treatment system that actually collects the water from that sump, removes the mercury, and then discharges it to the stream. There's a secondary, well, let me finish that story first. The monitoring data over time subsequent to the installation of that treatment plant has given us very good news. Basically, before the treatment plant, we had concentrations in the stream that exceeded ambient water quality criteria, basically regulatory criteria specified under the Clean Water Act. And we also had levels of mercury in fish in White Oak Creek, the small stream that runs just to the south of the plant, that exceeded Food and Drug Administration levels for the consumption of fish. Both those situations have now been reversed. The levels have dropped off to the concentrations in water are below what the Clean Water Act allows. The levels in fish are below what the Food and Drug FDA levels would allow. So that's been a reasonable success. There was also some mercury discovered as part of the recent ARA-funded building takedown activity. My information on this isn't as complete because I didn't have enough time to research it. But basically, as they were removing some buildings in the 3,000 area, that's what we think of as central campus, the old part of the lab, they did find some isolated, localized areas of mercury, actually metallic mercury, in some of the soils beneath one of those buildings. The building's been removed, the soil has not been excavated. There's not any evidence that that mercury is sufficiently dispersed or voluminous to have impacts on groundwater or surface water, but it's another one of these soil cleanup liabilities that we'll have at the lab. Until we can clean it up, it will be managed like all the other areas of soil contamination at the lab. It will be posted, there will be penetration permits required to go into the area. So basic industrial hygiene measures will be used to ensure that workers don't get into a mercury exposure situation. That's pretty much the mercury story at Oak Ridge National Lab. I don't want to leave anyone with the impression that it's widespread. That's the Y-12 challenge, but at Ornell we don't have a huge mercury issue. There also was some beryllium contamination found in some soils associated with some of the building takedown work. Again, part of our future soils cleanup challenge at Ornell. For the most part, though, our hope is at Ornell to, as funding becomes available and as real estate is cleared off, substantial areas of real estate, then we would go in after the soils. So we don't anticipate a lot of significant soil cleanup at the lab in the near term. The exception, of course, is for areas where we know we have an immediate anticipated land use, such as in the northwest quadrant, where we hope to do some redevelopment, or in areas where it's clear there's an ongoing groundwater problem that needs to be addressed, such as tank W1A. For the most part, though, we don't see a lot of soil cleanup at the lab in the near term. So that's that. Bob, did you have a question?
Is all the mercury there elemental mercury?
The mercury that was detected after the cleanup was actually visible elemental liquid mercury. I would guess, though, that since it's been there for a while, some amount of it has been methylated and converted to other oxide or organic forms. But the mercury that was detected was actually visible metallic mercury. Steve?
Thank you for following up. I was the one that asked the question based on information that I'd received on mercury. Beryllium's a different issue, and we would hope that there's not much of a beryllium problem. No reason to think that there is necessarily, but in going through historic documents, I've come across references to beryllium, and I'll put those together as best I can and share them with you at some point in the future.
Any more questions for Dave? Okay, we'll move on to our EPA liaison, Connie Jones.
Thank you. I would like to make one announcement, and I don't want to take Mr. Kopodik's thunder away, but the ETTP RA project team had a very good meeting today on the Zone 1 ROD and trying to move it forward. So we're actively working on trying to get a better understanding on how to proceed with that project and bring it to completion. Thank you.
Any questions for Connie? Okay, we'll move on to TDAC then with John Owsley.
Thank you, ma'am. I have no announcements tonight, but would be glad to attempt to answer any questions the board may have.
You have something, Steve? Go ahead.
I didn't have a question for you, John. I wanted to ask.
My time to the Department of Energy.
Thank you. Can either one of you update us on the status of the MOU with regard to the K-25 situation?
Sure, be happy to. What Steve is asking about is the MOU with various signatory parties for historic preservation of the site. We are busy revising our plan based on comments received. There's not a lot of significant changes to the plan. However, we have been asked to provide some more detailed information and also to consider a few modifications. And in the meantime, so that activity is going on. In the meantime, of course, we were hoping that the National Park Service would be submitting their evaluation and their report to the Advisory Council on Historic Preservation. The Advisory Council asked the National Park Service to do that. I think last time we got together, Dave talked about their visit here so that they could better be informed in order to prepare that report. We were hoping to receive some word that that report was delivered to the Advisory Council by the end of this week. However, there is a chance that that report may not be delivered this week, but instead there may be a short delay. So in the meantime, we are revising the mitigation plan in accordance to other comments that we've received. And it is our plan to provide that revised version to the signatory and consulting parties for their information so that they can be considering that while we wait for the National Park Service to give their information to the Advisory Council. You have anything to add, Dave?
Kind of saying the same thing Sue said, but we are proceeding with the redrafting of the MOA under the hope and presumption, somewhat at risk, that the comments that the Park Service tenders don't call for significant changes in the approach that we employ for interpretation at ETTP. That allows us to stay as close to the schedule as we can. But we have to wait and see what the Park Service says. And Sue's right, it'll probably be a week or two late on their part.
Go ahead.
Has there been any movement or resolution or action towards the resolution of the NDPDS permit for Y12?
It remains under appeal, but of the 5 projects that the state listed in the NPDS, one of them, the relocation of the flow augmentation point, was considered to be a non-FFA project, and Y12 NNSA is proceeding with that project. The other 4 projects are still a focus of the DOE Oversight Division and our negotiations with the Department of Energy and the Federal Facilities Agreement, but whether or not those will actually be completed as part of the NPDS permit remains under appeal.
Any more questions? Okay, if not, we'll move on to our public comment period with our student representative, Amira Sakala.
The public comment period is now open. Please state your name and keep your comments to 3 minutes. Norman Mulvaney.
Good evening, I'm Norman Mulvaney. I'm the Vice Chair of the Citizens Oversight Panel. Our new chair, Steve Kenworthy, is over there against the wall. For those of you who don't know, we're a replacement for the Local Oversight Committee Citizens Advisory Panel. Tonight, you're going to hear the second or the third or the 14th version of the story on East Tennessee Technology Park. It's a good story. There's one thing, I've already mentioned this to Jim Kapotic, that the issue with the map on the front of the document is really kind of interesting. It says City of Oak Ridge. Everybody take a look at that. It says City of Oak Ridge on there. That is not the City of Oak Ridge. There was a lady who was the member of this board for many years. She was on the original board. Her name was Pat Rush. She was a member of City Council. And she would go crazy when somebody would put up a map like this. So, in honor of her, I'm going to go crazy. The way that went down was in 1949 when they incorporated the city. Or 59, I can't remember which it was. No, they specified that the entire reservation should be included into the city limits. There was some people pushing back against that from the Atomic Energy Commission and from a few other places. They were successful. And if you'll look on this map very carefully, in the upper left-hand corner, where the words ETTP are written, you turn it on its side like this, there's a section right there with a line drawn across it. It has a dotted line around the outside of it and a line drawn across it underneath that red arrow. That is the only part of the reservation that is not on the that is not in the city limits of Oak Ridge. It's 806 acres. And it was a mistake. Anyway, I just wanted to be sure everybody was aware of that. The issue is, of course, that if anything untowards happened or any good news or bad news, whatever the issue was, that the city of Oak Ridge could be properly identified. Okay, thank you very much.
Thank you for your comments. The public comment period is now closed.
It's going to be quick tonight. We'll move on to our presentation for the evening, which will be by Mr. Jim Kapotic. Get you here. It will be on the East Tennessee Technology Park cleanup. Jim began his career with DOE in the early 90s as a site manager with the formerly utilized Sites Remedial Action Program, FOOSRAP, where he managed the cleanup of numerous sites in the Northeast. In 1997, he was the project manager for the ORNL surface impoundments, Goodnight tanks, and Phase 1 tank W1A soil removal action. Since 2000, Jim has worked at ETTP and is currently the DOE Portfolio Federal Project Director for the site.
Thank you, Maggie. I'd like to thank Maggie and the board for inviting me here tonight to talk to you. I don't really know where to stand. You're a little bit cramped in here. Maybe I'll jump out here. I'd like to recognize Mark Ferry, who is the project manager for UCOR. I'd also like to recognize Cheryl Cabell. Cheryl is over Environment, Safety, and Health and Security for UCOR. I'd also like to recognize, I don't know why he did it, but a motorcycle riding buddy of mine from Knoxville who drove all the way to Oak Ridge just to probably poke fun at me after this is over. I've worked with Connie. This is going to be like going back and looking at old family photos. So if you see Connie tear up, it's probably because she's had to work with me since 2000. But also, too, I think looking back at our accomplishments, I think it's, we've accomplished a lot. That's my objective tonight. All right, Norman has already pointed out. I will fix that map. Norman, thank you. East Tennessee Technology Park is located in the northeast corner of the reservation and the city. It's comprised of 5,000 acres. The administrative footprint is 5,000 acres. Construction started at the site in 1943 on the K-25 building. which was completed and operational by 1945. December of 45, we had 27 online, and by 1954, we had the other 3 gaseous diffusion plants up and operational. All right. We've been spending a great deal of money and over the past, 10, 12 years at ETTP. The entire site has no mission except for cleanup, and once we get the site cleaned up, we're going to turn it over to the private sector for use as a commercial industrial park. Our annual mortgage costs are $70 million a year, and that goes to keeping the lights on, keeping the power, security, and I'll get into some of the security stuff here in a minute. Once we complete the mission, we'll be able to release a huge amount of mortgage that can be used to further clean up the reservation and accomplish EM's mission. And I mentioned already our end state is a commercial industrial park, and that was decided, when was that, Connie and John and Sue? That was back early 99, 2000, 96. All right, all of our buildings are old. 2 of them I mentioned were constructed during World War II. The standards were a little bit lax at the time because we were in the middle of a war, and we needed to have these plants operational. They're contaminated with radionuclides, PCBs, asbestos, and they not only pose a risk for releases to the environment, they are in poor condition, and I'll show you some photographs here. And the sooner we get in there, the better off we'll all be. They pose a risk to the workers that are actually going in the building to complete the activities that we need to demolish them. We've got 3 burial grounds on site. All of those have been dealt with, again working with the state of Tennessee and EPA. We do have contaminated soils and groundwater, and I'll get into that here in a second. All right, the administrative footprint, as I mentioned, is 5,000 acres. Zone 1, we started out in 2000. We're working with Connie, and I know Connie was instrumental. We've got a process we've referred to as a dynamic verification strategy. Because we had such vast areas of land, we sat down and defined using the MARSOM process and EPA's the site program, came up with a process that streamlined how we would go out, collect samples, collect data, collect information, define what needed to be addressed, what was clean enough that met our cleanup goals for the site. And then, of course, many of you know we had ORISE come back in and do independent verification once we completed the cleanup to independently verify that the site, in fact, was clean. All right, the ROD was signed in early 2000. We have completed all the activities. That whole area there that you see, that's 1,400 acres. We've completed all the activities required under that interim record of decision. We're actually going into finalizing that ROD and making it a final ROD. The only thing that we might need to address, and we're anticipating we've got 5 to 7 acres down in Zone 1. It's contaminated with asbestos that we will end up capping, putting a 2-foot cap over it, which will reduce any more monitoring and any kind of maintenance activity. The area in the site out there, you all know, familiar with this area, is very shallow. You start digging 4 to 5 feet and you hit into groundwater. So whereas the rest of the site, the vast majority of the site, we got the end-use, SSAB's end-use working group. They looked at and they said, we need to have 0 to 10 feet below ground surface to facilitate use as an industrial park. So 1,400 acres in Zone 1 have been addressed. Inside Zone 2, it's 800 acres, and inside that area, if I'm not mistaken, Connie and John, we've addressed 200 acres. So it leaves 600 acres left in Zone 2. The remaining balance, the 2,800 acres, it's all out in this area. We have been working over, the last 4 or 5 years with EPA and the state of Tennessee to redefine the NPL boundary based upon aerial flyovers, aerial photographs, walkovers. A lot of the state was involved in the footprint reduction, so we've evaluated all that data, and we're very close to checking the box, redefining that, and getting agreement. So early in calendar year 13, I'm optimistic that our actual 5,000 acres will be necked down to 600 acres that are remaining for us to address. All right, I mentioned groundwater. Early when we got started, there was a little red dot up in that area where we exceeded drinking water standards. That's where the 1078 burial ground was located. All the areas where you see the plumes are associated with activities involving degreasing operations and things like that, so that they could clean the equipment up and do upgrades on it. In this area here, you got, this is 1401, which is a major maintenance facility. We've got 1070B burial ground. Right here is the 1070 CD burial ground. Early on, there was a rod to go in and remediate the G pit, which is a source for that plume right there. So there's a lot of source actions that have been conducted to minimize the continual release of things into groundwater, but also to stabilize the groundwaters and prevent off-site releases. All right, here are some of the key things that we've accomplished in Zone 1, and I'll show you. I put some photographs together just so you'll see. Down in the scrapyard, where I mentioned we have the asbestos, we had 48,000 tons of scrap that had to be size reduced and disposed of. Many of you remember all the cylinders that we had around this site. We had over 7,000 cylinders. All of those have been removed from the site. This is the 1078 burial ground that I mentioned, which is up in the northwest corner of Zone 1. That was a 1-acre site that we've remediated. And then there's Blair Quarry, where we had some contamination that had to be remediated. And there's the G pit, which is in Zone 2. And we're just now completing this. This is the 1070B burial ground, which is located just to the east and slightly north of K25. All right, this is a photograph of the site around mid-90s. There's K25, a mile long and 44 acres, a 44-acre footprint. There's 29, 27, 31, 33, the centrifuge facilities. There's 1401, that's right at 400,000 square feet. There's 1420. So we started out in the early 2000s cleaning up Zone 1 because there was minimal structures out there, and that's the closest proximity to the public. So we started out in that area where we could start our cleanup while we were demolishing facilities in the interior of the site. All right, K29 was the first building, gaseous diffusion building, demolished in the complex. We recently completed K33 demolition, and that's 32 acres. What made 29, 33 easier, many of you may recall we call the 3-building D&D project, where all of the equipment inside the building was removed prior to demo. These buildings are post-Cold War buildings, so built to a different construction standard, in a lot better shape than K25 and 27 building. 1401 building, which was that large maintenance facility located adjacent and just east to K25. And then the 1420 building. All right, K25. The West Wing demo was started in December of 2008, and that's been completed. UCOR's been brought on site. And this photograph right here is not really representative of where we are. That was right at about 6 units, if I'm not mistaken, right, Mark? By this point, Mark is already up to here with his demo crew, well past the 1600 building. The approach that we are taking, because there's a lot of discussion, you may recall we hosted a Tech 99 workshop back in March of 2011, if I'm not mistaken, I think, to make sure that people understood what they were bidding on. There are 5 units down in the lower end east wing of K25 that were used as a purge cascade when they brought reactor returns back, and the reactor returns were contaminated with Tech 99. So the approach was to air gap the building, This entire wing right here was working with Connie and Angel Perkey with the state of Tennessee. We got approval, demo ready for that, crit and credibility, so we started demolishing. We air gapped the building and then started moving north. We're proceeding along that path, and by later this fiscal year we should be done with that. We'll move into the north end because we're optimistic we're going to have the MOA, so we're not slowing down and stopping. While that's going on, UCOR's got sampling crews down in the tech area characterizing that, so we'll be able to know where that line of demarcation is, what equipment can go west, has to go west, and what equipment meets the EMW, the Environmental Management, Waste Management Facility, our circular disposal cell, the waste acceptance criteria, so we'll know how much we have to ship west and how much of it can stay here in East Tennessee. And we're on track to completing the demo of K25 by 2014, July of 2014. This kind of just gives you a pictorial. All of the west wing's gone, the northwest bridge, the northeast bridge is gone, and right now UCOR is up to 10 units that have been demolished. This picture right here doesn't really show up with the lighting. One of the things that UCOR, one of their core values is to dispose of waste as they demolish the building. So while the demolition isn't proceeding as fast as it could go, I bet Mark could almost have the entire east non-tech wing down by now. Then what we've got is a big pile of waste that you have to deal with. So they're basically, their mantra is pack as you go. So as the building's coming down, they're doing everything they need to do to ship that waste, and it's sort of it's just a rhythm that they're moving through the site on. What's important, why we segmented the building and got rid of this was so that we've got crews inside the north end doing work, moving materials out of the vault. We've got, and plus two, the north end was part of the MOA, so for safety reasons, by segmenting the buildings like this, we've got 3 work fronts. The north end, this is off limits to all the workers, and then crews are inside collecting the remaining samples we need to be able to determine where the material's going. This is just a photograph to show you guys the size of the building and what it looked like when the air gapping was taking place. Same sort of shot, but from a different angle. This shows the building itself. For the most part, the width across the building is 400 feet, and it's a mile long, and it's 65 feet high. This is the vault area. What you see here is the cell floor where all the equipment's located. That's the motor, and then there's a compressor, converter, and then you have the same setup on the back side, compressor and motor. There's an actual converter sitting right there in the pile. Those are number 2 converters, and they're like 5.5 feet by 8 feet in length. All right, one of the things we've been doing, and Sue's been instrumental in pushing K27 building. We need to transition the workers from K25 over to 27. Those of you who are familiar with 27, from the outside, it's kind of like a storefront. From the outside, the building looks like it's in pretty good shape. But up on the inside, we've got holes, and if I'm not mistaken, this is the largest hole in the building, and it's right at 6 feet by 8 feet. There's continual rainwater running inside the building. The roof is off limits. The floor inside 27 is a poured floor, so it's not in as bad a shape as the floor on 25, which many of you remember we had a gentleman fall through the floor in January 2006. That resulted in us having to change the demo approach, delaying the cleanup and costing more money. So it's really crucial that we get in there and complete demolition of the 27 building. And I kind of view it, and Mark and I both talk about K27 is just 9 more units tacked on to the 5 units that we already have in the tech area. All right, just to summarize, and this is a little misleading because there's a complication factor. We call everything on site that has a number a facility. But K25 is 44 acres under roof. That's one facility. A weather bus station that somebody stands inside to get out of the weather, that's a facility. Well, we all know it's a whole lot harder to tear down K25 than it is to remove So the heavy lifting is, and I'll get to a shot here that'll give you a pictorial of it, but the heavy lifting is for the most part, over at ETTP. We do have soil that'll need to be remediated on site, and we still need to work with the state of Tennessee and EPA to address the groundwater. But for the most part, we all know when we have projects around the house or in our jobs or maybe in school studying for a test or doing a term paper, you know when you've turned the corner and you say, I can see light at the end of the tunnel. Your vision of what your project is kind of comes in. You say, man, this thing is taking root. Well, that's kind of where we are at the site. And this shot right here might kind of show that. This is where we started in 2000. And what we have now is 29 is gone. 25 is well on its way, and we're moving out on that. We'll be done in July. We're moving the workers over into 27. 31 building is in good shape, and all the equipment's been removed, so there's really minimal risk there. 33 is gone, and then you look in the center of the site, all the facilities that supported the centrifuge, they're all gone. The 1401 and all the change houses right there, they're all gone. So what'll be left? We have a few buildings right here. You can see them. We call them Poplar Creek. We'll have the centrifuge facility. We'll have 1037, which is right here. We'll have Tosca and CNF, and they're relatively speaking compared to everything the work that's been accomplished to date, they are small in comparison. So my last shot here is just, and this is not supposed to, as Sue says, this is not the site as it's reindustrialized. This is just my vision that the land is open for business and that we've accomplished our mission, we've cleaned the site up, and now the private sector, Crowett, the city, have at it. It's ready for you guys to turn it into whatever you want it to be. So that's it. I'll entertain any questions.
What does it look like over there where these trucks are putting all this materials?
Oh, you talking about the EMWMF?
Yeah.
I mean, it looks like a disposal cell, but it's a real clean operation. I mean,
It looks busy.
Yeah.
They're moving in, 50-something trucks a day. But it operates pretty much like a standard demolition landfill. Yeah. Yep.
Are they
Filled in.
Trucks.
to begin with on concrete base or what?
Trucks pull up to dump ramps deposit material into the working area of the cell, and it's pushed around and covered with daily fill.
Will wind up over there in that.
provided it meets the waste acceptance criteria, and we've got a whole, that's almost another whole discussion on that process, but John and his folks are involved in that in EPA.
I have a pretty good feel for how the technetium got there, and to find out that it's staying there in that one little section is kind of interesting to me. I don't have a feel for why that technetium didn't go through the diffusion plant. Why is it still at that one little
Because
section?
the rest of the fusion plant wasn't in operation. Well, we've got, Mark's got John Shoemaker. It was only the two units, the lower two units that were used as a purge cascade. Now it has, and we haven't completed the sampling. Mark, I don't know if you want to add to it, but it's bled up another unit. Right now is what it looks like. So we've assumed 5 units were totally contaminated. And you're right, there was a lot of concern that it would, when the purge cascade was operational through the entire building, and they brought feed in, it would run all the way up to the high enriched end, and as a result of that, that's why they put the purge cascade in, so those lighter materials didn't run all the way up to cascade.
Are you identifying the chemical form of the technetium?
Are we identifying the chemical form, Mark, of the...
Yeah, it's in, the reason that it's in that area is that thanks. Usually people tell me I'm too loud. The form that it's in, some of it's gaseous, some of it's solid. I mean, there's like 6 different chemical formulas I could get, but I don't have them off the top of my head. The reason that it's in those units is it's a lighter a lighter gas than the UF6, and so it kind of raced ahead through the process system and that's why they put the purge cascades in there to get it out. We've actually characterized a whole lot of it, and we're removing, as we suspected, most of the converters in those areas are going to have to go. As we speak, we're cutting those out, and we've taken the first converters out already now that are going to go west, and we're looking at the compressors and the piping, working with Connie and John and the state. So it's not as horrible as everybody thought. We're going to take the technetium stuff out and ship it west, and then everything that's left is going to be below the waste acceptance criteria VMWMF, and we're going to stick it in there.
My only comment is technetium is not bad. They're all excited about nothing.
Oh, I was getting in trouble when I say that. It's it's bad. You're right. From a contamination and from a rad exposure standpoint, technetium is not a bad actor. What it is a bad actor is it's very soluble in water, and so it gets into the drinking water supply. And if you do scenarios with farming and things like that, that's where the technetium gets bad over time, starts to build up in your body. It's an internal hazard.
Not proven.
Oh, hey, maybe we can reopen the rod right here. You guys interested in that? No? Okay, I didn't think so.
I just want to remind the board members to please pull your microphone a little bit closer to you when you speak. If not, it's not going to get picked up. Thank you. Greg?
Jim, you mentioned when you started the $30 million, you called it mortgage cost, O&M cost, operating cost. When you're completely done, will there be any residual costs that the city or whoever picks up the property will be stuck with?
There will be minimal cost in that we have the 1070 CD burial ground. That will remain a classified burial ground. There's no materials in there that need to be removed from an environmental standpoint, but that will remain a classified burial ground. So there'll be some sort of a, security doesn't like you to say what they'll do, but there'll be minimal drive-by on a basis to make sure that the fences are up and that sort of thing. And then there'll be some environmental monitoring that we'll have to do.
Right, but those costs will continue to be carried by the Department of Energy or some other federal entity. They will not.
The city, whoever picks up the property.
Correct. Correct.
Steve?
In any project of this magnitude and complexity, such as tearing down K-25, you're going to bump into unanticipated surprises. Can you kind of summarize for us what some of those surprises might have been, both from a negative and a positive standpoint? I mean, some would obviously present problems in the tearing down of the building. Others might ease the project a little bit, make it unanticipatedly easier to tear something down. And from what we learn in demolishing K-25, what sort of technology transfer, knowledge transfer is there that helps us tear the next building down a little bit easier and a little bit more knowledgeably? And finally, is there anything to be gained from looking at the original building drawings, as built and plan drawings and so on? In what way has this historic knowledge been useful in tearing down these buildings nowadays?
Okay, I think the way we'll approach this is we'll just kind of banter back and forth between Mark and I. One thing is the last time the roof was repaired was '79. So from a maintenance standpoint, we didn't maintain the building, and that deterioration created a harder demo project than had we done maintenance on it. On the flip side of that, then the public might say, well, why did we not demolish it sooner? And it was always because we wanted to kind of hold it in the event that we needed it. I think the technetium, Mark he hadn't finished his study, but I think we all assumed that the technetium would be all 5 units, possibly even more further up. And so one of the things there to find out that it hasn't spread as far, that's a good thing. I'm impressed with one of the things I thought is that the demo crew, Mark, I got to give Mark a hand for the guys that he brought in on the team, the guy that's out there, the crew that he's assembled that is demolishing the building. We're actually 28%, if I'm not mistaken, Mark. We're like 2 or 3 units ahead of where we thought we would be as a result of his efficiencies and the way these guys are taking the building down. Just watching them move out there, the equipment, they're not messing around. Lessons learned, we have shared a lot of this information with Bill Murphy. One of the things we didn't do, which would have made it a whole lot easier on us for our security posture and everything else, would have been to purge the cascade. We didn't do that. So we have hold-up material. That hold-up material has required us to do additional things to convince John and Connie that we were good to go. So there's those kinds of things had we, and that all takes money. So we know what it's like. We're kind of in that situation right now. It all takes money. If you have a lot of money, I think everybody would say, we need to do this, this, and this to put the facility in a stable condition, and we need to have enough funding to maintain it so that it doesn't deteriorate, kind of like where it is now, so which has increased our cost and our difficulty. Now I'll turn it over to Mark. Maybe he's got some.
Yeah, that was a long question, but good stuff and bad stuff. Every time you come onto one of these DOE sites, you find the good stuff and the bad stuff. The labor force here, I can tell you, the building trades is one of the best, the safest, most knowledgeable, and they care and they want to work. This is a really good workforce that's out there. That's much higher than what I anticipated. The technetium is not as bad as the press. The building is not as contaminated with technetium as maybe some people were led to believe. By their very nature, what do the converters do? Well, we're not allowed to talk about what they look like on the inside, but probably most of y'all know. And that's where it is. And it's not all over the structure, so we're going to be able to get that. The EMWMF is the best waste landfill that I've ever seen. It's the most robust landfill, and it has a haul road on the site. So it's very important that we don't have to leave the site to haul our waste to EMWMF. That's very good. Some of the odd things that you find at every one of these DOE sites, people squirrel stuff away. And they don't squirrel away the easy stuff to get rid of. They squirrel away the hard stuff. And you find it. But we won World War II, and we won the Cold War, and I used to make power for a living and burned a lot of fuel that came out of here. So everybody gets a free pass from me. In the north end vaults, we found some equipment that's been poured inside concrete that's stuck in there, and we're chipping that away right now as we speak to get rid of that. And there's some high hold-up pumps and cold traps and things like that that were stuck in the vaults that we're going to have to get rid of. But nothing that I would say would outweigh the good stuff. Usually it just kind of balances out, and that's what I'd say here. I guess the biggest lesson learned, another part of the question, K27, I'd say the biggest lesson learned is go find out what you got before you start. Characterize the building. We're doing characterization, deactivation, and demolition all at the same time. And so you have to adjust your strategy as you go on how you're going to do things. In K-27, as Jim said, we're going to send our sampling crews over there that are experienced now, and we're going to know what that building looks like before we get started. I think that's the biggest thing that's going to help us, so we're not kind of guessing as we go along.
The only thing I'd say is for Portsmouth, Bill Murphy, once or twice a year they send down a whole group, and it was more intense early on, probably once every 2 or 3 months in the early 2000s, where when we first got started, we're sharing information, we're sharing DVDs of the demo, we're sharing our lessons learned, we're sharing surprises that week. I mean, you ask about surprises. We found a cylinder the other day. It's about like an oxygen cylinder up on the ops floor, and that was an unanticipated activity. So, but we got a process. We're dealing with it. So you get surprises, and you get, oh, that's a lot easier. I know Mark mentioned he's chipping away at the concrete. It's a whole lot harder than what we ever anticipated. So, I mean, that's a negative, but he'll work out a way with his crews and figure out a way to do that work faster and cheaper and safer. So, I mean, the surprises are nonstop, but the big thing for us, and you all know that K-25's been on everybody's hit list, the IG's hit list, but we're sharing that information with not only DOE complex-wide, but also with the Ohio and Kentucky, so that they've brought down, I know Bill Murphy sent down a whole entourage of folks from the state of Ohio to come down and look at our operation, look at the demo, and then to tour the EMWMF to see how it's being managed. So we're in a situation that at times is not as comfortable as you would like it. I mean, it'd be great if it was easy street the whole time, but at the same time too, the knocks are helping us to help others not make the same mistakes that we've made.
Gloria?
I think probably your information and Mark's already probably answered my question. My original question was that the experienced crew transition from K-25 to K-27. My original question is that are there any specific hazard or changes that were not included in the K-25 experience? But
yeah, we're carrying that over.
Yeah.
That's the beauty of taking those guys, and they're going right. And in fact, it's closer to go from the tech area over to 27 than it is to go from the tech area up to the north end. So.
Yeah, are there any specific unique changes for K-27 building structure? Anything compared to the K-25?
What do I do to this thing? Is it on? Oh, okay. The 27, the vaults are clean, so there's nothing squirreled away in there. The only difference is there's these cylinders there. They're of various sizes. They're called the Tech 99 cylinders. I don't know what's in them. We're going to find out, though. There's about 9 of them, and they're small, and we'll figure out a way to get rid of them. But if I had to think, Jim, of anything different than 25. I mean, there's no big concrete monoliths. There's no high gram stuff like that.
Right, and it's all low enriched in that it's less than 20%. The other big thing is the building is in a better condition. The panels up on the ops floor, after the gentleman fell through the floor, they were off limits, and we had to build these modular, we call them modular work platforms, to get up on the ops floor. On 27, it's a poured floor. Doesn't have the roof is in better shape. It does have some huge holes in it, but it's a poured concrete floor, so you can get up there and access the ops floor, whereas up on K-25 you can't. You've only certain areas, or you have to move a modular work platform over there to get up on it. So, if there's no more questions, I'd like to say,
Got Jimmy.
oh, there is one.
One more shot at this technetium. I think there's a lot of chemistry that could be learned if one looked at where the technetium is inside of your operation. Is there any way that a person can get a hold of that information so that he can look and say, hey, this was pertechnetate, hey, this was technetium oxide, hey,